All right, welcome everybody to Hands-on Machine Learning Engineering and Operations. Today we're going to be talking about model serving. This is the fifth core module. This is the last core module of our course, and today basically all of the hard work that we've put into creating a model is going to pay off, because we're going to be able to take the production model that we have trained and we're going to be serving these models so that people can actually use it in real life through a production API. And the way that we're going to do that is pretty cool. We're going to see a little bit of theory so that we understand what we do in the live coding session. And then we're going to move on to the live coding directly. And we're going to implement everything that we've talked about so far. We're going to see that there is a bunch of ways that we can do things, as always. But I'm going to try to be as complete and thorough as possible when I talk about the different technologies. And I'm going to try to help you figure out the strengths and weaknesses of each of the directions that we take as we move towards the deployment of this model. So today we're going to be talking about a bunch of things, from the way that we can design an API to the way that we can take this API and implement it in production so that we can deploy our model as a Dockerized solution or as a serverless solution. Obviously, we're going to define these two things. If you understand what I'm talking about today, then you understand the whole development cycle. So I hope that you're excited, and let's get into it. As always, I want you to keep in mind the whole development process that we have embarked on. And it started with the raw sample data here that we passed through a feature engineering pipeline so that we could get the feature store up and locked in our data warehouse, basically on BigQuery. And then little by little, we started to implement more pipelines so that we could have eventually a trained model or a production model that is exactly the model that we want to take and to serve to whoever wants to play the game of Ballot Mania. So we've reached this last pipeline here, this serving pipeline, which is going to be built on top of this trained model. We're not going to need anything else. We're just going to need this trained model, and we're going to be deploying this in production so that people can access the predictions that it generates through a REST API. And this is why the last artifact, or the last thing basically that we are thinking about preserving and managing successfully, are the predictions of the model. And as an extra, after we're done looking into the deployment of the API, we're going to check how we can monitor the drift of our deployed model. Because now that it's deployed in production and that people can actually use it, we're going to start getting some real life data, not just some training samples that we have generated artificially through, let's say, our self-play in the lab, but really like real world data of people using this model and telling us basically how good it is in real life. And this is why we want to implement this drifting pipeline, this extra pipeline that's going to allow us to monitor in real time, to monitor how well the model is performing in real life. So the first thing that we need to understand to go through this module here is that putting our model in production essentially means creating a way for people to access it, right? And one of the best ways to do that is to create an API, which is just an application programming interface, so that people can programmatically access this data. Now, why would people want to access this data programmatically? Well, if you think about it, first of all, if you look at the actual game here, the way that I designed this platform or this app is by having two services, right? One service in the backend that's basically like all the algorithms that allows us to know what are the best moves, to know what the AI should play at any point of time. So this is what I call the backend. This is the backend application, and this is just purely the algorithms that generate the best moves at any point of time. And I have a front-end application here, and my front-end application, in other words, the UI or like the web app that you see here, is very dumb. It doesn't do any processing at all. The only thing that it does is it gets some input from the user. So for instance, myself here trying to play, it gets some input from the users, and then it sends this input directly into the backend API where the model lives. And then it asks the model consistently, like, hey, based on these inputs from the user who's playing right now, what is the best move that the AI could play? And so this is exactly what we're talking about here. We're talking about an API that is set up basically in the back end of the application here, and that is allowing the front end to know what kind of actions it should show to any user who plays the game in real time, let's say, like in the actual app. Now, this is only one reason why we would want to build an application programming interface so that our app can communicate among its services behind the scene. But another reason is, what if instead of playing this game here through the UI or through the platform, what if I don't really want to play the game, but I just want to have access to the underlying recommendations of the algorithm? I don't really want to play the game, but I just want to see for a specific set of cards what would be the best action to play. And so this is exactly what we've been concerned with in this course. We don't really care about the game itself. We just want to see what is the best action to take based on cards. And to be able to access this data, we're not going to use the platform here. We're going to use a service that is called Postman. And this Postman service, don't worry too much about it. There's going to be a lab about this. But this Postman service is exactly what's going to allow us to communicate directly with the algorithm that's living in the Belot virtual machine. And the reason why we're going to be able to interact with the server is that on the server, we have set up an API that is serving us the recommendations of the algorithm. And the way that this API works is precisely like this. We use some kind of like application so that we can access the data. Here, for instance, when I play the game online, I basically use a browser so that I can access the data that's living in the server where the algorithm lives. And essentially what you do is you spin up like a web browser and you do an HTTP GET. So you basically do a request of data. You're like, okay, can you pass me some data that's living on your server? And you always ping some kind of remote server where this data lives. In this case, the data that lives in there is just basically the predictions that the algorithm does. And essentially what the server does is the server always interacts with some kind of like database where information is stored, right? Now I've been talking about Belot Manier, but if I go on any website in the world, if I just ask like news and I just go like on any news service and I ask for some data, this is exactly what's going on here. This is basically me just making a remote request to a web server where Google is hosting its news content. And essentially I'm asking the Google server to go check out its database and serve me, like extract any resource that I want to have access to, in this case, for instance, news, and serve me back this data so that I can view it in the browser. So looking at static data, if I go online, but if I go like on this web app here and I play Belot Manier, again, an AI, essentially what I'm doing when I play this and I click on stuff and I play, what I do is I'm interacting with this API, interact with the server, grab the data that it needs to grab from the DB. In this case, for instance, in the DB is the algorithm that generates the prediction, and then serves me back the content that I want to look at. And if we go deeper and really try to understand what is going on behind the scene, well, essentially what's happening behind the scene is that, I'm here and I spin up a web browser, and essentially when I play against the AI, what really happens behind the scene, like in terms of the API, is we have this ping-pong game between the API just providing some data to the server, providing some data, and these are just the features that the server needs so that it can feed the algorithm and so that it can provide back some kind of like information. And this is exactly what the API does. The API is this contract or this definition of data transmission that explains like what does the remote server need from the user, from the local browser? Like what is the data that this remote server needs so that it can serve the data that's required the local browser? And so essentially here, if I look at the game, basically data that the API is basically sending to the remote server is a full snapshot of all of the cards that are available. And the data that I get back from the server, from the remote server, is an idea of what the AI is playing, right? Because if I play, for instance, the Jack of Diamonds, now the data that I received back from the server is, who won the hand and whose turn it is, basically, whose turn it is to play. So who won the hand and whose turn it is, my turn. And so I can keep playing because whenever I send some data to the server by clicking on one of the cards, the server just gives me back some data by telling me like who won and what's going on right now in the current state of the game. Now, this is specifically for the game of Belot Manier, but essentially the API that we want to design for the training for this course, the API that we want to design is We want to design an API that would send as an input all of the features that are in our feature store. We want to provide all the features that are in our feature store, and the data that we would get back from, let's say, our server is a response that tells us the prediction, the win probability based on these features. And this is exactly what we've wanted to do since the beginning. Because if you remember correctly, our problem statement since the beginning was, given a set of cards that we are looking at, can we create a model? Can we build a model that looks at these cards and gives us a percentage probability of winning? And the answer is yes, we have successfully trained a model to do that. In fact, the model is quite decent at doing it. But now we want to make sure that people can access this model. And so the solution that we've always had in mind was, let's look at some cards that we are being dealt on the platform. We can be dealt any random card. And let's manually provide these cards to our model that is going to be put as a microservice solution online. Let's use this API, pass it some data, just give it like the cards that we can see, and receive an answer that tells us whether we're going to win the game or not. But we've already seen that a model cannot understand cards that are strings. This is a semantic interpretation that we understand as humans, not something that the model understands itself. So we first of all went through the whole process of creating features and stuff like this so that the model could be trained. Now the only thing that we need to do is provide new hands in real life that the model hasn't seen before, but use the experience of the model to let us know what is the probability of winning this hand. And so if we go back to the API that we are going to design, well, we're precisely going to design this API so that we can put our model online so that it can be accessed and used at any point of time. And the way that we're going to design this API is we're going to have to provide these features. That is already what the model should be able to understand. And we're going to get, as a response, a body containing some kind of predictions telling us how strong the hand is. And we're going to base our decision to play or not to play based on this prediction. And so don't worry too much if it's still a little bit fuzzy, like this whole thing is exactly what we're going to be doing together. So it's going to become much more understandable once we do it in practice. But essentially, how are we going to design and build this API? Well, there's two ways to do that. The first way is to build a there's more than two ways to do that, but the two ways that I could recommend doing are, first of all, creating a Dockerized deployment on a virtual server. That would be the first thing. And the way that we're going to do that here is we are here, and what we do essentially is we put our model inside of a container that contains all of the applications and all of the libraries that it needs to be able to run. And we put all the rest into other containers, such as the database and things like this, again, packaged with the applications and the libraries. And when you have, let's say, package these two things, you put them on a virtual server. And the process of literally taking this stuff and putting it on a virtual server is the deployment. It's going to make sure that because your model resides on a virtual server in the cloud, that people can have access to, that people can reach through the web or through HTTP request or whatever it is, because it is deployed online, people can access it at any point of time. In other words, your model is not just in a cloud storage space, like in Google Cloud Storage space, where no one can access it. Your model is on an online server with open access, with open HTTP access to it, and so it means that anyone with a connection to the internet and anyone with an access through a web browser can access this model once it has been packaged through this Dockerized deployment on virtual server. Now, the second way that we could deploy our model is through serverless architecture. And I think there's no better way to understand serverless architecture than looking at the contrast between serverless architectures and other kind of architectures, right? So if you think about it, I just said that there's a bunch of different ways that we can deploy a model online so that people can access it. And in general, the way that I think about it is that you can go from small microservices solutions, like the one we described with Docker, towards purely serverless architectures. And what it means essentially is that there is a different level of management that you're going to need to put into your deployment depending on which kind of solution you want to go for. If you go for a completely microservice solution, like pretty much the one that I described with Docker here, you're going to have to do this whole process of creating your container, packaging your model inside of your container, opening an HTTP access to your virtual server so that people can access it, scaling up and down, let's say, your server when the model becomes too big. Just a bunch of like manual management that you have to do for your deployment to work. And you can move away a little bit from these low-level managed services, not managed services, toward more self-managed solutions, like the one that DigitalOcean, Heroku, App Engine, all of these solutions that are provided by different providers, and that reduce the amount of management that you have to do for your solution to run, let's say, online. And then at the extreme, what you can do, and where we're going to focus a lot of time on, is the serverless solutions, where you just really literally have to put your model into a convenient location so that it can be deployed serverlessly and not really manage anything. And you're going to see what I'm talking about here. But essentially, I would want you to have one thing in mind. The more you move towards these serverless architectures, the more advantages or benefits you're going to get from a cost standpoint. And the way to think about it is that when you deploy a model on a virtual server, which is very similar to a virtual server that we have used for training the model, you remember that the cost model was basically that you pay for the uptime. Like every hour that your machine was up and running, you would pay some money, right? And this is fine for like training, right? When you train your model, you're actively doing some processing. And so you don't mind having this uptime model because you're just really paying for training processing, and that's fine. But when you are deploying a model and you're just like waiting around and people start using it, right? You don't really want to pay for uptime because not everyone uses it at the same time. And in fact, there might be like huge period of time where no one uses it at all. Like for instance, me, I have like strokes of time where no one just plays the game, right? And so I'm paying for uptime on a virtual server when no one is actually using it and connecting it, but I still pay for it because that's the cost model of microservices. But this is completely different for serverless architecture. You don't pay for uptime, you pay for runtime. So you don't pay for a virtual machine that's just running nonstop. You pay whenever somebody actually tries to access your API. In other words, whenever somebody is interested to know what is going to be the prediction for a specific hand, whenever somebody wants to do that, we are going to pay for this request. That is the cost model of the serverless architecture. And this is very, very, very powerful. This is actually great for us because it's going to minimize the cost and it's going to be allowing us to manage our budget much better. All right, so if everything that I've just been saying is extremely confusing and very, very abstract, don't worry about it too much. I think it's going to become much more obvious what's going on in the live coding session. So let's just not wait too much and let's just head over there. See you soon.